Welcome to the Trig Chapter 13 review video. We're going to go ahead and start off by looking at this first section, 1 through 10, and these are problems I would expect all of you guys to get right on the test. And I'm not going to go through every single one. I'm just going to go ahead and go through number 1, number 2, number 3, and number 5. And if you guys can handle those 4 problems, you will understand how to do the rest of them. So if we look at number 1, this is one where they're giving us the angle. We are trying to find the ratio, and the directions tell us to find ratios to 4 decimal places. So all I'm going to do is I'm going to type in cosine and then put in 41.22 and press enter. The calculator tells us 0.75218, so I'm going to round that to 0.7522. I can do this exact problem if it says cosine, sine, or tangent. If we look at number 2, it's a little bit different because we don't have a secant button on our calculator. So we need to think back to our ratios. We need to think back to our reciprocals. We've learned that cosine is the reciprocal of secant, sine is the reciprocal of cosecant, and tan is the reciprocal of cotangent. Since secant and cosine are reciprocals of each other, we're going to go ahead and type in our calculator 1 divided by cosine of 22 degrees. And when I put that in my calculator, I end up getting an answer of 1.0785. Number 3 looks very different because all of a sudden we are not trying to find the ratio. We know the ratio. We're trying to find this angle. We've talked a lot in class that whenever we are trying to find an angle, I always need to use my inverse button. So in this case, I'm going to do tan inverse and then type in our ratio. So when I put that into my calculator, I get 65.44965, and it goes on. But the directions do tell us whenever we're finding an angle, we're finding it to the nearest tenth. So our answer would be 65.4 degrees. The last problem I'm going to do here is number 5, which is secant of theta equals 2.2130. Once again, this is a problem where we are trying to find an angle, but this time it's a trig function that is not on our calculator. So we need to think back, what is the reciprocal of secant, and we know that it is cosine. So we know we need to use cosine inverse. So whenever we're trying to find an angle, regardless of our trig function, we know that we need to use the inverse button first. So I'm doing cosine inverse, 1 divided by 2.2130. And it gives us an answer of 63.1 degrees. If you can do these 4 problems, then you should be able to do all 10 of these. It really is just learning, am I looking for an angle or am I trying to find a ratio, and then figuring out, is it a trig function that is on my calculator or do I need to know the reciprocals? The next section on your test is going to be dealing with changing from degrees to radians. So we know that whenever we want to change from degrees to radians, we are going to multiply by pi over 180. Pi should be in our final answer, and we really just need to simplify whatever fraction we have left over. So let's go ahead and do number 11. So I'm going to do 300 times pi over 180. When I simplify 300 divided by 180, it reduces to be 5/3. So our final answer is 5 pi over 3. And this is how I would do numbers 11, 12, and 13. Okay, and then when we are changing from radians to degrees, that's when we multiply by 180 degrees over pi. And it should make sense because we can see that the pi's are going to cancel out. And when we're doing this, most of the time your denominator will be something like 6, 3, or 4. It'll go into 180 pretty evenly, and this is something we should be able to do pretty quickly. So when I multiply 5 pi over 6 times 180 over pi, the pi's cancel out, and 6 goes into 180 30 times. Then when I multiply straight across, 5 times 30 degrees is 150 degrees. I would expect you guys to do really well on questions like 1 through 16 on the test, so make sure you study how to do each of these. So the next set of problems here is 17 through 19. These are the types of problems that we know we need to draw a triangle on. Now on the test, it won't be set up like a chart. It'll just be asking you one specific trig function, like it will give you an ordered pair and you need to find secant, or it will give you cosine theta equals root 2 over 2 and you need to find tangent. So let's just do numbers 18 and 19. If we can do those, you'll be in good shape. So the first thing we need to do is draw this out, and I can tell that an ordered pair of -3/8 is going to be in quadrant 2, so I went ahead and drew a triangle that would be in quadrant 2. -3/8 means we're going 3 to the left and 8 up, and then in order to find the hypotenuse, we're going to have to use Pythagorean theorem. So once I go through and use Pythagorean theorem, we end up getting that the hypotenuse is 5 radical 3. Now we have all the information we need in order to find the 6 trig functions. We know sine is opposite over hypotenuse, so I would get something like, sorry, for some reason I added completely wrong there. 9 plus 64 is 73, not 75. So that gives us that our hypotenuse is radical 73. So now we can go through and do our trig functions. I know sine is opposite over hypotenuse, so I get 8 over radical 73. I know that that should not be our final answer because we should never have a radical in our denominator. So I'm going to rationalize it by multiplying by radical 3 over radical 3. Once I do this, I end up getting 8 radical 73 over 73. When I do cosine adjacent over hypotenuse, I get -3 radical 73 over 73. Our tangent value, opposite over adjacent, is 8 over -3. Make sure that we are always going off of our reference angle, and that is the one that's closest to the origin. As soon as I know these first three, now I can just find the reciprocals. The reciprocal of cotangent is tangent, so that's going to be -3 over 8. The reciprocal of secant is cosine, so I get negative radical 73 over 3. And the reciprocal of cosecant is sine, so I get radical 73 over 8. On the test, as I said, you would just be asked to find one of these. So the last problem I'm going to go through on this page, number 19, it gives us a trig function. And we know cosine is adjacent over hypotenuse, so that is actually telling us these two sides of the triangle. So I'm putting radical 2 on the adjacent side, and 2 is the hypotenuse. I knew this was in quadrant 4, and we've learned previously all students take calculus, and that means that the only trig function that is going to be positive in quadrant 4 is cosine. And then we would also know that the reciprocal of that it would be secant, and that is also going to be positive. Now I can use Pythagorean theorem to figure out this missing side, or I could recognize that it actually is a 45, 45, 90 triangle. So the two legs, it really is an isosceles triangle, so these two legs here have to be congruent. So I end up getting that it is negative radical 2 over 2. From there I can go ahead and I can figure out the sine is negative radical 2 over 2. Cosine we know already is radical 2 over 2. Tangent is -1. Now we can do the reciprocals. The reciprocal of tangent is cotangent, so that would be -1. The reciprocal of cosine is secant, so we get radical 2. And the reciprocal of sine is cosecant, so we get negative radical 2. So the key thing on these types of problems is I need to be able to draw a triangle. I need to remember all students take calculus, know if I'm going to the right or going up, it's a positive side, going left or going down is a negative side. Okay, so now we're going to take a look at problems that deal with solving the right triangle. The first thing we know right away is that our right angle is angle C, and this triangle is really given to us if we want to draw like around it, just so we can know exactly what we're looking for and what sides are opposite, hypotenuse, and adjacent. Since we know two of the angles, I started off by using our triangle sum theorem and knowing that all three angles have to equal 180. So I did 180 minus 111.1, and 111.1 is the sum of the other two angles. So we end up getting that angle A is 68.9 degrees. Now I really have a lot of different options as to what I want to find first. I'm going to go ahead and find side A. And I prefer to always use the information that's given to us already, so I'm going to use angle B, which is 21.1, and the side that's given to us is 13.4. So if I look at angle B, which is up here, A would be the adjacent side, and 13.4 is the hypotenuse, so I know that that would be cosine. So I'm going to do 13.4 times the cosine of 21.1 degrees equals side A. So side A is 12.5. Now we have options. I could either use sine to help us find that other missing side for B, or we could use Pythagorean theorem because we know that this is a right triangle. So it is definitely open-ended as to what we want to do. Just for practice, I'm going to go ahead and use sine. So I'm going to do sine of 21.1 is equal to B over 13.4. So 13.4 times the sine of 21.1 is equal to side B. So we end up getting that side B is equal to 4.8. And if we look, that makes sense because we know that the opposite side has a relationship with the angles. We know that the biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle. So 4.8 would make sense here. We're not going to go through 21, but for number 21, the key thing to remember, we're going to set things up the same way. We just need to know whenever we're finding an angle, that's when we use the inverse button. Our next section deals with our special angles, and this is something that you guys have spent some time memorizing. Just a reminder on, let's see, on Wednesday and Thursday, on Thursday and next Monday, you guys are going to be having a quiz on this. So, first thing we're going to do here is I'm going to go through one like number 23. So, I personally would start this off by adding 360 degrees. I'm going to do that just so I have a positive angle to work with, and that gives me 240 degrees. So if I'm going to go ahead and draw this out, and I'm just going to draw it down here, I know 240 is in quadrant 3, and the key thing I need to think about is how far is 240 away from 180? How far is it from the closest x-axis? So in this case, it ends up being 60 degrees away. Okay, so some of you guys drew this out and would go, oh, well, 60 degrees, that would be negative radical 3. Opposite from 30 would be negative 1, and the hypotenuse would be 2. And then you could go ahead and do all the ratios that we need to know. For others of you, you might just go, oh, it's a reference angle of 60 degrees. That means that the sine is radical 3 over 2, the cosine is 1/2, and tangent is radical 3. And then you would use all students take, since we're in quadrant 3, I know tangent is the only one that's going to be positive, so I'm going to make those other two negative. Then we could find the reciprocal, so it'd be radical 3 over 3, and then negative 2 and negative 2 radical 3 over 3. So go back, look in your notes. You guys should either be memorizing the two special triangles or memorizing those 9 trig functions and then using the reference angle to figure those all out. So if we look at the next page here of the review worksheet, the key thing here is it's talking about non-right triangles. So you need to make sure to pay attention to what the directions say on the test. So with non-right triangles, the two things that should jump into your heads are law of sines and law of cosines. And we talked about sometimes we'll be able to use either one. Sometimes it's very specific as to which one we need to use based on the information given to us. I'm going to go ahead and go through numbers 28 and 29. And the thing to remember is normally when we are only talking about one angle, that's when I'm going to be using law of cosines. When we're dealing with two angles, that's normally when we use law of sines. So even though I'm not going to do these other ones, just kind of to look through it, number 30, since we have 3 sides here, and we're just trying to find a single angle, I would use law of cosines. That's when I would need to use cosine inverse on. For 31, we're dealing with 2 angles, so I'm going to use law of sines. And then for 32, I'm dealing with 1 angle, so I am going to use law of cosines. So for number 28, I'm using law of cosines. Since we're talking about angle B, I had to put side B all by itself. And this is a nice problem because my unknown is already pretty much isolated by itself. So I can go ahead and put all of this straight into my calculator. So in my calculator, I get 22.91. Now that is a rounded value, so I need to make sure in my calculator to keep that entire decimal value in there. And when I square root that answer, I get 4.8 as our final length for B. Remember, I could not use Pythagorean theorem to try and find this answer because this is a non-right triangle. For 29, since we're talking about two angles, I am using law of sines. So when I set this up, I can tell that I do not need to use sine inverse because we know both the angles. So I'm just going to start by cross multiplying. So I have a times the sine of 30 degrees equals 8 times the sine of 40 degrees. I want to get a all by itself, so I'm going to divide both sides by the sine of 30 degrees. And this is something that we can just put straight into our calculator. The important thing for me to remember, though, is that when I'm putting 40 degrees in, I need to make sure to close that last parenthesis. And I end up getting a equals 10.3 in my calculator. So make sure I know how to use law of sines and law of cosines. Now let's move on to area. I would definitely expect to have a problem like 27 and a problem like 28 on your test. So for 27, since they're giving us three sides, I know I'm going to use Heron's formula, which is k equals s times s minus a times s minus b times s minus c. So the first thing I need to do is find what is the semi-perimeter. So that's adding all three sides together and dividing it by 2. So when I do this, I get 9 divided by 2, or 4.5. So once I substitute all those values in, and I actually went ahead and subtracted, this is the formula I end up getting. So I'm going to go ahead and just put that straight into my calculator. And I get 2.9 square yards as my answer. I do need to label this, and since they gave us that it was yards, that's the label that I'm going to use. Now you could have also solved this if you had used law of cosines and found one of the angles. We could have used our other area formula, which is k equals 1/2 AB sine C. And the key thing when we use this formula, we talked about how C is what we call the included angle. So you could have solved it that way as well. On 28, I'm definitely going to use this formula, so let's just go ahead and substitute everything straight in. So when I put this into my calculator, I end up getting 3.4 square feet. Make sure that you know both these formulas. Remember that if you are only going to memorize one, this is the one that I would make sure I know how to use. However, I'm letting you know the two problems on the test will be similar to these. So now we're going to go ahead and move on to the word problems, and I'm actually going to go through every word problem. The word problems will be like this, where we're not quite sure, is it a right angle, or a right triangle or a non-right triangle. So we really need to pay attention to the problem. This one says, how far from the base of a building? So I'm going to go ahead and draw a building. Is the bottom of a 30-foot ladder that makes an angle of 75 degrees with the ground. Now, based on this, I'm assuming that it is a right angle because buildings are normally vertical. So, if I am trying to find how far away it is from the base, I know the base is down here at the bottom. So I'm going to go ahead and label this bottom side X. Now I'm going to use this as our reference angle, so this would be the adjacent side and this would be the hypotenuse. So I'm going to write cosine of 75 degrees equals x over 30. So in my calculator, I'm doing 30 times cosine of 75 degrees. And I end up getting that 7.8 feet is equal to that adjacent side. So this is a good example of some very basic problems, remember that we call this angle here an angle of elevation. Number 31 now is a more difficult type of problem because it has this angle of descent. So this angle of descent is up here. So it's like the plane's here and it's flying down here, so it's going at an 11-degree angle. It starts from a height of 9,500 meters, and it says what distance measured along the ground at what distance must from the airport must the pilot start the descent. So the problem is this is not part of our triangle. However, we can see that these two are the same length. So I can go ahead and just write up here that this is what we're trying to find. Now looking, this would be the adjacent and this is the opposite. So I'm going to be using tangent of 11 degrees equals 9,500 divided by x. Some of you may have chosen to use cotangent instead, which is fine. When I multiply both sides by x, I get x times the tan of 11 is 9,500. So then I need to divide both sides by tangent of 11 degrees. And I end up getting an answer of 48,873.3 meters, which actually seems pretty reasonable because 9,500 is opposite 11 degrees. I know this angle is going to be 79, so x should be much bigger than this side. So the next word problem, it says opposite corners of a small rectangular park. Okay, so I'm going to go ahead and draw a rectangle. And the fact that it's a rectangle tells me that these are all 90 degrees, so I am going to be dealing with a right triangle here. And it says they're joined by diagonals that intersect at 65 degrees. And if I know if that is 65 degrees, that this side over here, these two angles need to form a linear pair. So it's going to be 115 degrees. Now I know that each of those diagonals is 360, and one thing we do know about a rectangle is that the diagonals bisect each other. So we're actually dealing with two different triangles here that look like this. So even though we're dealing with a rectangle, the two small triangles we're working with do not have a right angle in them. So since we only have one angle, it looks like we are going to be using law of cosines. Now if you really wanted to, we could do some work to find the other angles and you could use law of sines, but I think using law of cosines is going to be easiest here. So I ran out of room, but you can see I use law of cosines, and this is one I can just put into my calculator and square root it, and I end up getting 193.4 meters. Now to find the other side, so this y value, I'm going to use the same exact formula except for instead of 65, I'm going to use 115. So I end up getting 193.4 meters and 303.6 meters as the sides of our triangle. Now moving on to 33. 33 is actually very similar to the problem that we did in our trig trek where we were trying to find the height of the ladder. And what shows me that is the fact that I have these two different angles of elevation. So I'm going to start by going ahead and drawing out our picture. So when I draw this out, it's really little, so it's tough for me to draw these, but I know this angle is going to be 59.5 and this is going to be 62.2. I labeled X and Y, and it looks like to find the height of the tower, I'm going to have to find this height and subtract this height. So I'm dealing with adjacent and opposite, so I'm going to be using tangent here. So these would be the two different trig functions that I'm going to be using, and once I find those answers, all I'm going to do is subtract. So I end up getting 49.8 meters. This is definitely the type of problem that I would expect you guys to be able to do on the test, where I'm dealing with two different triangles and I'm trying to figure out how I can find that unknown. Whenever what we're looking for, like here, is not a part of a right triangle and I have right triangles, I'm thinking I need to use two different triangles. So if we look at number 34, 34 we know is not a right triangle. And the reason we know it's not a right triangle is because one of the angles is 102 degrees. So I went ahead and I know that every single picture we have should form a triangle. So this forms our triangle right here. I know this is 800, 500, 102, and I'm trying to find UV. Now since this is a non-right triangle, I'm thinking I'm either using law of sines or using law of cosines. Since we're dealing with one angle here, I'm going to go ahead and use law of cosines. So there's the formula. Since I was using 102, I use UV as x. I can use any variable I want there. Since my variable is all by itself in my equation, I just need to put this in my calculator and square root my answer. I end up getting 1,027.8 meters, and that answer is logical because 102 degrees is the biggest angle, so that means that UV should be the biggest side. So our next problem, number 35 here, once again, they give us these two angles, so I know it is not a right triangle. And I went ahead, I know the observers are 30 kilometers apart, and those are the angles that they can see joining their two positions. And this problem's asking us for two different things. They're asking us how far away is it from the one observer and from the second observer. So it looks like we're going to have to use two different formulas. This time, since I have two angles and it's a non-right triangle, I think that we are going to be using law of sines. So looking at this, I went ahead and found the third angle by adding 52.8 and 83.1 and subtracting from 180. And then I went up and set up this trig ratio. And you guys at this point should be pretty good at solving this with cross multiplying and dividing. So my formula would look like that when I multiply and divide. And now I can just go ahead and put that into my calculator. And I've said this a few times, but it's really important for us to go ahead and close that second parenthesis. So I end up getting y equals 34.3 kilometers. And then I'm going to go ahead and do this same exact equation, except instead of using 52.8, I'm going to use 83.1. So I'm going to replace it right there. So instead of rewriting everything, I just went ahead and substituted 83.1 in where there was 52.8 and put x instead of y. And I end up getting x equals 42.8 kilometers, which if we just look at our sides, it makes sense that x should be the biggest side and that 30 should be the smallest side. So number 36, this is a basic type word problem. Two thin strips of wood, 9 centimeters and 10 centimeters, are glued at one end, making a 33-degree angle. So that's what I went ahead and drew, and we're trying to find what would this other side be. So since we are only dealing with one angle, I'm going to use law of cosines. When I go ahead and put that in my calculator and square root the answer, I get 5.5 centimeters. And I'm guessing that 33 degrees is the smallest angle, so it would make sense that x is going to be less than 9. So 37, I went ahead and drew it. We have a hill here that has a slope of 60.2 degrees with the horizon. And then a siding at the top of the hill has an angle of elevation of 27.6. So that's 100 feet, and we need to find this side. So I'm going to go ahead and use the fact that these two form a linear pair. So that angle right there is 119.8 degrees. Then, if I know those two angles, I can add those and subtract from 180 to go ahead and find this third angle of the triangle. And I get 32.6 degrees. Since we're dealing with multiple angles here, we are going to go ahead and use law of sines. So to figure out what angles I want to use, I know I have to use 100. So I need to look and see what angle is opposite from 100, and that would be 32.6 degrees. The other side I'm going to use, I know I need to use y, so I'm going to use the angle that's opposite from y, which is 27.6 degrees. At this point, I can go ahead and cross multiply and divide. And I end up getting that y is equal to 85.99. So I'm going to make that 86.0 meters. And our last problem, and I'll let you know there is one on the test similar to this. I know in class We talked about angles with direction, north, west, southwest, and dealing with that. This is a similar idea. So it says two snowmobilers start from the same point and drive, and it gives us their speeds, diverging at an angle of 110 degrees. Then it says 2 hours after leaving. So we need to think for a moment here. Since the one is driving 10 kilometers per hour and they've traveled for 2 hours, I know that they've traveled 20 kilometers because I did 10 times 2. Same idea, 12 times 2 would be 24. And I need to figure out how far apart they are. This is one where since I only have one angle, I'm going to go ahead and use law of cosines. So I'm going to go ahead and write that all out right now. Now before I even put this in my calculator, I'm guessing x should be the biggest side since it's opposite 110. When I put that in my calculator and square root it, I end up getting 36.1 kilometers. So continue to study for your test. Make sure you guys feel confident in all the stuff on this review worksheet, and you should be in great shape for the test later this week.